one. Actually, I will call this pre and post. So this, Eddie, I don't remember what you ended up with for your design.
Oh, I did between subjects.
You did between subjects?
Yeah.
Okay, so if you did a within subjects design, then this will probably be relevant for you. I'm going to just make up numbers here. You should consider doing this for your thesis. Look at how fast I collected this data. Numbers on the post, I'm trying to make them bigger. Not obscenely bigger, but somewhat bigger. Okay, so so this is another example of a 2x2 ANOVA. In this example, you have one variable called condition that is between subjects. So participants are all in here together, and you signify whether or not they are in condition 1 or 2 by just putting it in the cell for that participant. And then you have a repeated measures, or sometimes called within subjects factor here. So every time you have a within subjects factor or repeated measures factor, that single row gets multiple measures. Because remember, it's one participant took the test twice, so they should have 2 scores, sometimes even more, if you have like repeated measures over more time. So that makes this a mixed model. You have one factor that is between subjects and one factor that's within subjects. And so to calculate the 2x2 for this, it's actually a bit more complicated. You go to general linear model just like last time, but it's a repeated measures design, is what SPSS chooses to call it. On the first screen, it's funny because here it's called repeated measures, and then here they call it within subjects. You think they would be consistent. So here you can label this factor whatever you want to call it. And I would probably call it something like time, right? So use pre or post. And it has 2 levels. It's either pre or post. If you took multiple measures and they had more columns, then you would put that number here. But for here, we only have pre or post. So you click add, and then you can move on and push define. This within subjects variable tells you where to put your within subjects factor. So we have pre and post, and so those go here. And then any between subjects factor goes into the between subjects factor box here. That should make sense. If you want some options for looking at means, again, you could do the same thing. I always look at the means because I think that it's helpful for knowing what exactly you're looking at when you're looking at the F-test, what means you're comparing. So push continue and OK. And so here's the output. We have condition 1 with 10 people, condition 2 with 9 people, and these are what your means look like, but we'll just scroll down. So you can see already that you get, once you have a within subjects factor, you get a lot more boxes than you got before. So here are the within subjects effects. And the within subject factor for us was time, right? Actually, I want to be here. The within subjects factor was time. And so that's represented here with this time effect. So this tells you what the main effect of time is. And to know what that really means, you probably want to look at the means for condition. So here we can see that condition 1, I want to look at it for time. So time 1, which is the pre-measure, they had a 4.5 in terms of regression, and post they had a 6.889. And so this main effect of time with the within subjects contrast here tells us that that difference, those 2 numbers are significantly different from each other. The p is less than 0.05. So you would report F And you report the degrees of freedom as 1 and 17, which I didn't tell Tiffany to do, but the degrees of freedom for an F test, you actually get 2. So you put 1, 17. And then you report this P. So again, that just means that these two numbers are significantly different from each other. That was a pretty big effect. Then for the other main effect that you get is condition. And so that's actually given to you with the box that says between subjects factor. Because condition is a between subjects factor in our design, right? You're either, let's say, in an exercise group or in a non-exercise group. You're either the group that eats or you're the group that doesn't eat. And so this was also significant. This P is less than 0.05. So you report this as an F parenthesis 1 comma 17 close parenthesis equals 5.32. P equals 0.03. And what this main effect is telling you is that the difference between these two numbers, condition 4.75 and 6.67, are significantly different from each other. And finally, you get the interaction effect, which is part of the within subjects contrast. And that is not significant. So what that means is that the effect of time on condition is not significant. So pre and post doesn't matter whether or not you're in condition 1 or 2. That main effect isn't qualified, we would say, by time. So we report this as an F 1 and 17 equals 0.15, and P is equal to 0.71. And so the other way to think about that is to look at these means down here. And it basically tells us that the crossover means, so here compared to here, and 6 compared to 5.56, is not significantly different from each other. So that's how you would